So let's consider the problem where the crate is pushed up. Because of friction, it will reach a certain height before it stops and slides back down. The details are given in the problem. Again, using mechanical energy, we get K1 plus U1 plus the work done by the other force, in this case friction, has to equal K2 plus U2. So in this case, the other work, as we've seen before, is going to be K2 minus K1 plus U2 minus U1. And you notice it's the change in kinetic energy plus the change in potential energy, or the change in mechanical energy between the two. So this is going to be given by the work done by the friction force, which is the friction force times some kind of S, which we're calling this distance, or actually better yet, this distance. So this is going to be K2 is 0 because it stops at that point, right? And U1 is 0 because it has no potential energy at that point. So this is going to be U2 minus K1 equals the force of friction times the distance up the track it's going to go. So this means that the force of friction is the change between the kinetic energy initially, the potential energy finally, divided by S. And as we know, U is equal to M, which is 12 kilograms. G is 9.8 meters per second squared. And it went up the ramp 0.8 meters. 1.5, I'm sorry. Yeah, 0.8 because that's the height difference. Minus the kinetic energy is 1/2 m times the velocity that it leaves with, which is 5 meters per second quantity squared. And it only goes up a distance of 1.6 meters up the ramp. If we do this, we get about 35 newtons as the force for friction. And now for part B, we're asked how fast when it reaches the bottom of the ramp. So we can say the new work of friction which is for going up the ramp and coming back down, equals 2 times F, which is 70 newtons, right? Because there's 35 going up and 35 coming down. Times the distance of 1.6 meters gives us a value of 112 joules. And now we can say, again, K1 plus U1 plus new work of friction equals let's call it K3 plus U3. But keep in mind that point 1 and point 3, as explained in the graph, are exactly the same on location-wise. So K3 in this case is going to equal K1 plus U1 minus U3 minus work of the new friction force. And K1 is 1/2 times 12 kilograms, which is the mass, times 5 meters per second quantity squared, plus U1 minus U3 is 0 because they're exactly the same place, plus the work of friction has to be negative because it opposes the motion. So if K1 is going up, the work will be going down, and if it's coming down, the work is going to go up, so it's always going to be the opposite of the motion. And that gives us about 38 joules. And we know that K3 equals 1/2 m V3 squared. So V3 by itself is square root of 2K3 over m, or the square root of 2 times 38 joules over 12 kilograms, which gives us a speed of about 2.5 meters per second.